A key component of learning neuroscience is developing a strong understanding of the major structures of the brain and their relative locations. The goal of this MSD project, P21099, is to create a realistic brain model that accurately showcases the primary anatomical structures for use in an Introduction to Cognitive Neuroscience course at RIT. Here are the members of the Dissectible Brain Model team.
In simple terms, customer requirements are specific demands made by the customer that outline what they are looking for in a product. Customer requirements help to guide the design process so teams can produce an ideal product. Some of our team's most important requirements were to create a brain model that included visible anatomical features and had a similar color, texture, and weight to that of a real human brain while ensuring that the model will be dissectable, reusable, and safe to use.
The brain model is composed of 8 separable components. These include the brainstem, the cerebellum, 3 slices of the right hemisphere, which include the transverse top, middle, and bottom, as well as 3 slices of the left hemisphere, the coronal front, middle, and back. These brain components were modeled in CAD software to help determine exact slice locations, which are intended to help showcase many of the internal brain features as possible, while still minimizing the number of overall components needed.
The best identified method to create the brain model is using the molding process. PLA plastic was the chosen material to 3D print our molds because of its cheap cost, versatility, and ease of removing the model from the mold. Magnets are being used as a latching mechanism to hold the model together and allow for the simulation of the dissection process. Metal dowel pins were inserted into specified locations in the molds for proper magnet positioning.
Silicon, specifically DragonSkin 20, was identified as the best material to use to fill the molds in order to align with our customer requirements. To fill the molds, identical volumes of silicon A and B were mixed thoroughly and pigment was added to match the color of a human brain. The silicon was placed in a vacuum chamber to remove air bubbles and then was poured carefully into the fill hole of each mold. After the molds were filled, there was a 4-hour cool time before the molds could be disassembled and the model could be removed.
Dissection is a key requirement for this project. In the Introduction to Neuroscience course, students will use a 3D printed scalpel to dissect each hemisphere into its 3 corresponding parts, and a 3D printed probe to point to and identify anatomical structures. We would like to thank the following individuals for their continued support and guidance throughout the course of this project.